All right, let's get started again. Okay. We haven't talked much about strings. And strings are different from ints and booleans and chars and doubles because those latter four are primitive values and strings are objects. And here's the difference. The primitive values are built into Java. They come with operators to manipulate them. So you get plus, minus, times, divide, greater than, less than, and, or, not, and so on. And that's a fixed set of operators. And anything you want to do with those values, you have to be able to do with the operators. Then Java has classes. And each time you create a class, we've been using classes to hold static methods. That's one reason you have classes. Another reason is to create new types of data. So every time you create a class, you're creating a new type of data. And then you, as the definer of the type of data, get to decide how values of that data can be manipulated. So the string class, it comes with Java, but it's sort of implemented using Java as opposed to being implemented, being primitive part of Java. So let's talk about it. String objects have a special status in Java because they have literals. You can literally, if you want the string hello, Java provides the syntax where you just put double quote hello, and then you have the string hello. It doesn't provide this for any other kind of data defined by classes. So there's 3 examples of string literals. Now suppose you have a string object. What questions might you want to ask about it? Yeah.
How long it is?
Okay, what's the length of it? So you might ask, what's the length of that string hello? The answer would be 5. So you might want to know how long a string is. What's something else you might want to ask? Yeah.
What's the third character?
What's the third character? Okay. Got a different one?
Is it equal to another string?
Okay, are these 2 strings the same? You think of anything else you might want to ask about a string? Yeah?
It contains another string or a char.
Okay, does it contain you could say the string hello, does it contain HE as a substring? Or does, so those are all examples of things you'd like to be able to ask about a string object. So when we talk about objects as opposed to primitive values, objects don't typically have operators. There aren't operators that you use to work on strings. There are methods, non-static methods. So non-static methods or just methods, are the way that you are allowed to manipulate different types of objects. So when you want to learn how to use strings, you have to learn what methods are provided. So let me show you. You can think of strings as ways of asking questions about the object. So we'll assume that S, S1, and S2 are string variables. They contain strings. So to get the length of S, you say S.length. So there's one difference. With the static method, when you run a static method, you give the name of the class it's from, dot, name of the method, then parameters. With non-static methods, you give object dot method parameters. So you're always operating on some object. All right? So S.length, if S contains world, and then you get back 5 when you ask its length. Okay? You can ask what character is stored at index 2, and that's charat. So charat, world.charat of 2 is R, because the indexes start at 0. So W is at index 0, O is at index 1, and so on. So you got to get used to this. It is object, dot, method, and then parameters. You can take a substring. You can say, give me the first 3 characters of S. So what this means is you're saying, give me a substring of world that begins at index 0 and goes on for 3 characters. So you get back WOR. That's another thing you can ask a string to do for you. You can ask, what's the index at which the character D occurs? So you're saying world.index of the character D is 4. It's telling you D occurs at index 4. You can ask whether S1 and S2 are the same. So yes, the string yes dot equals the string no is false. Okay? So everything I give you, there's an expression that you could, so this is a new kind of expression. An expression where you invoke a method on an object. And it looks a little strange at first, but you get used to it. Okay? There's a whole bunch of string methods you can find by looking at the string documentation. So let's compare now static methods versus methods. So there we're calling 2 static methods. Right? We're saying, give me the square root of 5, parse this string into an int. And to do it, we have to say, you have to give the name of the class the same name of the method. Okay, here are some non-static method calls. So here you give the object followed by the dot, followed by the method, followed by any parameters. So non-static methods are invoked on objects. You're asking a question, making a request of an object. Now, you might think if Java would be more consistent, you would, instead of saying math.square root of 5, you would say 5.square root. Ask 5 to compute its square root. And it's different. You can't do that with primitives. You can't invoke methods on primitives the way you can on objects. That's just the way it is in Java. Now, essentially, when you're asking for the index, this index out here, there are really 2 parameters. There's the object on which the method is being invoked, and then there's whatever parameters, in this case, just this one parameter that's in the parentheses. So there always has to be this object on which the method was invoked. And the name for that is the implicit parameter. So in this case here, S is the implicit parameter, S is the implicit parameter. That's the object on which the method was invoked. So when I use the term implicit parameter, I'm talking about the object in which the method was invoked, because it has a distinguished position. It's at the beginning in front of the dot instead of being in the list with the rest of the parameters. It's the thing being operated on. So let's look at the documentation for char. It says, returns the char value at the specified index. Index ranges from 0 to length -1. Okay? It says it returns the char value at the specified index. At the specified index of what? Right? It just takes an integer as a parameter. How does it know which string we're asking for about the index? It doesn't. The parameter does not show up in the list. So what's the answer? Yeah?
Well, the string that you're calling the method from.
Right, the string that you're calling the method on, the implicit parameter, that's what it's having. So really it should say returns the char value at the specified index of the implicit parameter. But if the documentation was always explicit about the implicit parameter, we wouldn't call it the implicit parameter. It's implicit because it's assumed that you know that this is referring indirectly to the object on which the method was invoked, the implicit parameter. So it doesn't show up in the header anywhere. But how do you know that this method has an implicit parameter, whereas square root does not? What about the header tells you that there's an implicit parameter involved here? Yeah?
Is it because there's no static?
It's because it doesn't say static. If it doesn't say static, then this method can only be called, it has to be invoked on some string object, the implicit parameter. And we know that the implicit parameter of this method is a string just because this method belongs to the string class. Now, we're not going to be implementing any non-static methods for a long time, perhaps for a month. We're going to be using non-static methods because, right away, because you can't do anything with strings unless you do so. Yeah.
Are the scanners
Yep, scanners are objects, and so they have methods. Yep. Okay, which brings us to scanners. Actually, let's come back to scanners. Let's go into JShell and try some of this stuff out. Okay, so I should be able to find out the length of my name. There's a length method that takes no parameters. I'm asking Joe, that Joe is the object in which the method is invoked. I'm asking its length, and it tells me 3. What if I wanted to multiply the length of my name by 2? How would I do that? I just do that. Joe.length is an int expression, and I can multiply it by 2. So you can mix and match. This is just a new kind of expression you can use. Okay? What if I wanted to take my last name and ask for the character at index 3? So what character is stored at index 3 of Zachary? H. So it'll say H. What if I want to ask, does Zachary, is that the same as Joe? Are those two strings the same, basically, is what I'm asking. And it's going to tell me false. Okay? So as an aside, never do this. No, it's too long to type. Never ask. It's very tempting to compare two strings with double equals. And sometimes it work there, and sometimes it doesn't, for reasons I don't feel like explaining right now. If you want to see if two strings are the same, use the equals method. Don't use double equals. I can explain that later, but for right now, just don't do it. Just use double equals to compare primitives until I say otherwise. Okay? Now, what if we do this? I'm going to create a string, S. It contains hello. How can I find out the length of S? S.length will tell me the length is 5. Okay? Now, strings are kind of unique in Java because not only do they have literals, they have an operator. You can add strings. You already know this. What happens when you add two strings? It appends them together. So how can I find out the length of the string that you get by appending S and S? I just do S plus S dot length. Because S plus S is a string, and I can ask it its length. Okay, so just get used to this, that you give the string, and then a dot, and then the question, and then if any parameters are needed, you give those as well. All right, so that's strings. Yeah?
So S plus S is the implicit parameter?
Yes, in this case, this last case, S plus S, which is the string hello, hello, is the implicit parameter to length. That's the string you're asking the length about. Okay. Now, back to scanners. So scanners are another useful class. When you create there are various ways to create a scanner. For now, we'll create scanners by passing in strings. And what they do is they allow you they break strings into tokens. We'll talk about what tokens are. Essentially, we'll talk about what tokens are in a minute. There are no literals. And so this is how you create a new scanner. So for every other class besides string, if you want to create a new object of that type, you have to use what's called a constructor. So new scanner, this is a test, creates a scanner that's going to tokenize the string, this is a test. So that creates a scanner that gets its input, gets its text from that string right there. Now there's another way to create a scanner. You can create a scanner that takes its input from the keyboard. We'll do that sometimes. What's new on here that you've never seen before? Or at least we haven't talked about in class before. Okay? Well, system.in, we have seen, yeah, I guess that's true. We've seen system.out, that's input. System.in is the keyboard. What's the other thing? Yeah? Constructor, particularly that keyword new. Okay? So that's what we're going to talk about here, how to use a constructor. So here's the simplified documentation for the, I guess it's the real documentation, for the scanner constructor, for a scanner constructor. And you can see, well, look at the header. What's unusual about the header of that constructor right there? Yeah? There's no static, that's true. What's missing besides the static? Yeah?
There's no type.
There's no return type. So it looks like a method, but there's no return type. What's also interesting about the name of this thing that looks sort of like a method? Yeah?
Doesn't it like replicate the name of the class?
It's the same as the name of the class. So the class is called scanner, the constructor is called scanner. That's how you know you're dealing with a constructor. So a constructor is how you create objects. The other methods the class provides are for manipulating objects of that type. But the constructors are for creating objects, in this case scanners. So you can see it constructs a new scanner that produces values scanned from the specified string. We know it's not a method because there's no return type and the name of the thing is the same as the name of the class. That tells you it's a constructor. And when you, we'll go back here, to use a constructor, you say new. You're saying give me a new scanner. Create a new scanner from, this is a test. Create a new scanner from system.in. So constructors are needed to create objects except for strings. Strings you can just say double quote. Okay, so let's look at how you use scanners. So I'm creating a scanner that's going to read its text from that string right there. So one thing you can ask is the next chunk coming in an int? Is the very next, imagine that it breaks that into the chunks 23, 55, and hello by the white space, which is roughly what it's doing. Okay, so the scanner breaks things into chunks or tokens, and we're asking, is the first token an int? What's it going to say if you ask? It's going to say true. Then you can, and suppose we say, okay, give me the next int. Give me, what you're asking there is give me the first token, and it better be an int. What's it going to give you back? It's going to take that first token and turn it into an int. So we get 23 out. Now, what if we ask, again, is the next, and the thing to realize is, when you take the 23 out of the scanner, it's gone. What's the new first token now, after you remove the 23? 55. So if we now ask, next int, it doesn't just give you the 23 back, it modifies the state of the scanner so that it's got different thing in it now. So now when you ask, does it have a next int, what's the answer going to be? Still true, because that 55 is sitting there. And if you asked for it, you get 55. Now, what if you ask, does it have a next int? False, because the next thing coming up is hello. You can just ask, does it have a next token at all? And the answer is true, because there is still a token in there, it's hello. To get it out, you say s.next, and it just gives you back a string hello. So scanners are good for pulling strings apart into pieces. Yeah.
So you said that when we say next integer and it gives you that 55, it basically takes it away from the original. Is the same apply to has next integer?
Now, has next and has next don't modify the scanner at all. They just tell you what's coming up. It's when you call next int or next that the scanner is modified. Yeah.
You said constructor, and there's two scanner in this article, and I'm just wondering which one is actually the
Well, okay, so you're asking about the constructor. There's only one scanner on this slide, S.
also like the variable that we
S is a variable that contains a scanner. Yeah. So in that very first line of code, we create a new scanner object, and then S now refers to that object. And so then we start operating on S. Yeah,
Does it have to go from left to right?
yeah, it scans from left to right.
There's no way to skip over like the first imager?
Well, if you wanted to skip over, you would just say s.next and then ignore what you got. Yeah.
So on documents, the control F function that searches for words, is that a scanner?
Well, it's not a scanner. The question might be, does it use a scanner? Yeah, it's hard to say. It might. Yeah?
What if you use double space? Would it count the one space as
Yeah, if you have multiple white space, it doesn't care.
How about
Yep.
punctuation or commas?
Yeah, punctuation and commas it would care about. I don't want to spend a lot of time getting too precise about exactly how it breaks things into tokens. In our case, it's always going to be breaking tokens at white space. You can customize how it breaks things into tokens. The reason I'm looking at scanners is they're useful, and also it just gives us, I wanted an object other than string to talk about. Okay? What happens when we asked, is there a next token after we've gotten hello out of the scanner? Yeah, it's going to say false because the internal string is now empty. So this fact that scanners can be changed, the term is mutable. Scanner objects are mutable. You can operate on them and change them. Strings are immutable. There's nothing you can do to a string to change it. You can't go in and replace a character in a string. All you can do is like make a copy and that's slightly different. All right, let's look at scanners in JShell. So I can say scanner, I'll call it R just for variety, equals new scanner. This is a test. And then I'm going to, you can sort of ignore what was printed out there. I don't know why. 1, 2, 3, 4. Okay, that's not what I meant to do. I meant to give them two different names. All right, so now S is the this is a test scanner, and R is the 1, 2, 3, 4 scanner. So what happens if we ask S if it has a next int? Okay, S does not, the next token is this. It's going to say false. If we ask that same question of R, it's going to say true. They're two different scanners. All right, what's going to happen when we say s.next? What do we get out? We'll get this out. What if we say r.next? Remember, R contains 1, 2, 3, 4. We'll get out 1. Will it be as a string? Yes. So we get 1 as a string. Now, what if we say r.nextInt? Now, remember, when you say nextInt, you say, give me the next token, and you're requiring it to be an int. If it's not an int, weird things will happen. What are we going to get back when we ask nextInt of R now? Remember, initially it contained 1, 2, 3, 4. We already pulled the 1 out. What happens if we ask to give me the next int out? Okay, it'll give 2 as an int this time. Now, what if we go to S and ask for the next int? I'm not asking if it has a next int. I'm saying give me the next token, and it better be an int. Right. We get an input mismatch exception. And we'll eventually learn what exceptions are and how to deal with them. But this is just telling you that the next token is not an int. Now, what if we ask if S dot has if the next token is an int? It's going to say false. Why did it say false? Oh, yeah, S was the one with no ints in it. Okay? There are other methods like has, next, double, and so on. Okay, let's actually write some static methods. Let's do this method right here. I'm given a string S and a character C. I want to know whether that string contains that character somewhere, ignoring case. So say I have a string capital A, capital B, lowercase c, and I ask, does it contain lowercase b? I want the answer to be true. I want to ignore case when deciding whether or not a character is in there. So how can we do that? Yeah.
There's a object thing where you do s dot. I think it might be like substring or something, and then you put in a specific phrase that it's looking for.
Okay. So yeah. So to paraphrase what he said, it's nice to we know there's a method index of, right? That's S is a scanner there. So if we say hello.index of O, it's going to say 4. What happens if we ask, does it contain an X? Returns -1. So we've got a way to find out whether a character is in a string. Yeah?
So in the word hello, there are two L's. Which one would it pick the first one or is it the second one?
Oh, I think it picks the first one it finds. Question? Okay. So what if we just did this? Return s dot index of c. Greater than 0. Okay. So what we're doing is we're getting the index of the character c in the string s, and if that index is greater than or equal to 0, we're going to be returning true. Otherwise, we're returning false. Does that work? Well, let's try it out. Let's do hello, let's do contains. Does hello contain the string, the character O? Oh, I forgot to give the It does. And what if we ask whether it contains an X? It says false. What if we ask, does it contain a capital H? It says false. And this thing says case doesn't matter. So we're not quite there yet. We've got the beginnings of an idea. But how can we deal with the fact that, that we got to ignore case? Yeah?
Isn't there a method in Java that converts everything to lowercase?
Okay. So there's a method called toLowerCase. So it gives you back a new string that's just like the original string, but it's in lowercase. Does that solve our problem? So we're converting S to lowercase before we look for the string. But that's still going to return false. Now if we had this situation, we get true back. What are we missing? Yeah.
Isn't there a method called like ignore case, like index of ignore case?
Well, there may be a method index of ignore case, but I don't want to use that if there is. I don't know if there is. Yeah?
What do you want to do? I was going to say character, like the char, and then you can't put the char for the
Right. We need to convert C to lowercase as well. Now, is there going to be a method on C? Can we say C dot to lowercase? No, because it's not an object. Now, one thing I didn't point out when I did this, if you do S dot, look what it does. It shows you all these string methods you could use on it. That's called IntelliSense. And you can use that. If you're wondering, is there a method that will do index of ignoring case? You could scroll down here and look. We have to look for a static method, and it turns out there's a class called character dot to lowercase. So this is a static method that will convert a character to lowercase. Now we're in business. reload. Static demo 2, let's see, that should still work, right? And that's working as well. So what's the lesson here? What was involved in doing this? What do we have to know in order to do it? What did we figure out along the way? Yeah.
Some of the methods in string and like how to use them.
Okay, so we had to be familiar with what methods are provided by the string class. Okay? The germ of the idea was, okay, we got a simple way to check whether a string contains a character by using index of. And then we can just look at what we get back, and if it's not -1, we know that the string contains a character. And that was the beginning of the idea, so we had to use that method. But then we saw that it doesn't quite work to deal with the case, and so we had to, what you have to do, this is sort of the creative leap you have to do, is say, well, what I've got will solve the problem if everything is in lowercase. So why don't we just convert everything to lowercase? And then once you do that, the problem becomes, how do I convert to lowercase? And at that point, you have to think, surely there's a way to convert a string to lowercase, and indeed there is. And surely there's a way to convert a character to lowercase, and indeed there is. So it's not like you have to have all these things memorized. You just have to know how to find out about them. So how do you find out what methods the character class provides? If you don't know. You could go read the documentation, but that's not what most people do. What do most people do if they want to know what the character class provides? You just do character dot in Eclipse, and it'll show you these static methods you can apply to characters. And if you want to know about what does hashcode do, you click on it and it shows you what hashcode does. Same thing, if you've got an object, you want to know what methods you can apply to it, you just do object dot and you see the methods. You're essentially reading the documentation, but you don't have to leave the Eclipse window to do it. Let's try this one here now. I want to return the sum of the first 2 tokens of S, where S is required to begin with 2 numeric tokens. So when it says it's required to begin with 2 numeric tokens, that means if it doesn't matter what we do. All bets are off. We're not making any guarantees about what this method will do unless the string S begins with 2 numeric tokens. So for example, I'd like to be able to do this. What should that give me back? I give it a string. I say add the first 2 tokens. What are the first 2 tokens? 23 and 45. So I would expect to get back 68. It'll be a double, so I'll put the dot there. Okay? So it's got to take the string apart, get out the first 2 tokens, and add them up. Well, you know how to add, right? You use plus, but how do we get tokens out of a string? Is there a method that will, s dot get first token from string? You might try that. You might say, okay, is there a way to pull the first token out of a string? And you're not going to find one. Rats. What's the inspiration? Yeah.
Put it in a scanner.
Put it in a scanner. You know how to get tokens out of a scanner, and you know how to create a scanner from a string. So we're going to say scanner scn equals new scanner, and there's S. How do we get the first token out of the scanner? The first double out of the scanner? It would be next double here. So that will get the first thing out of the scanner, and this will get the second thing out of the scanner. And then what do we return? D1 plus D2. Done. Nope, not done. Now done. Okay? That's programming. It's taking things you know how to do, You know how to take things out of a scanner. Something about my voice seemed to suggest I was done to you, but I'm not. So don't get up yet. We know how to get tokens out of a scanner. We know how to make a scanner out of a string, and we need to find a way to get tokens out of a string. So you just have to have the aha moment that says, we just got to put things together. So programming is just figuring out how to put these things together. There's the nuts and bolts of knowing you got to put the static keyword in the static variable and making the braces and ending with a semicolon. Okay, that's learning the syntax. But to be a programmer, you got to be able to have all these facts about what a legal program looks like, and you got to be able to make these little leaps to put together things that you know how to do a thing you don't know how to do. So let's look at one more, then you can leave. Suppose I give you two scanners and I asked, do they begin with the same token? Okay? How could you compute whether or not two scanners begin with the same token? Yeah? He said put them into strings and then compare them, but I don't really have a way to convert easily a scanner into a string. And again, I don't want to know whether or not the scanners contain equal characters. I just care about the first token. Okay? Well, how do we even get the first token out of the two scanners? Okay, what do I have to write here to get the first token, the token out of the first scanner? S1 dot. Next. And let's save that somewhere. I'll call it R1. Okay, that's the first token in the first scanner. How do I get the first token out of the second scanner? Control C. Let's do the same thing. I'll call it R2 is R2.next. And then I got to return the answer. How do I know if the first two tokens are the same string? R1 dot equals, not double equals. That's right. So again, we took what we knew how to do, which we know how to get the tokens out, we know how to compare strings, and that's what we do there. We just pull out the first string from each token and compare them using equals and return the result. That's programming. So you'll be doing programming like this involving strings and scanners and primitive values for PS2, and we'll talk some more about this next week and in the lab.